Okay, guys, limits. We've been talking about those. And as we look at this graph, give me 3 ways to solve a limit problem for this particular graph. What's one thing we could do to figure out a limit? Plug values into the polynomial itself? Okay. What else can we do? What did you do yesterday on your assignment? We made a table. You made a table. You can make a table and look at it numerically and see what's happening. What else can we do? Okay. Make the equivalent graph without the calculator. Is that kind of helpful? What are 2 things you can do in your calculator? What are those functions? The trace function and what else? Table function, right? Or you could evaluate. Can you always just plug it into the equation and then figure out what the answer is? No, you can't. How come? Sometimes it might be undefined, right? So, when we look at this particular picture, do we see any holes or any asymptotes? No. For situations where there are no holes or asymptotes, you could just plug it into the equation itself and figure it out. And it's not really a big deal. There's some other rules that I want to talk to you about. It says to let b and c be real numbers, and n is a positive integer. Complete each of the following properties of limits. So if we're looking for the limit of b as x approaches c, so we're looking for the limit of some just number as x approaches a different number. That means that the f of x function had to have been, I don't know, somebody give me a number. 25. I think I heard 25. Great. So let's pretend it was 25. So they're saying find the limit of 25 as x approaches c. What does that graph even look like? What's the graph of y equals 25? What's that look like? That's just a straight line of 25, right? So if I say what's the limit as x approaches 0, what is it? 25, because we're coming in on 25. What's the limit as x approaches negative 10? Also, 25. Is it 25 every time? Yeah. So it's whatever b is. The limit of x as x approaches c. So this equation that they're talking about is they're saying that f of x is x. Y equals x. What's that graph look like? A line with a slope of 1, right? When x is 1, what's y? When x is 25, what's y? So whatever x is, that's what y is, right? So as we are looking for the limit as x approaches c, let's say if I said, as x approaches 25, what's the limit? 25. As x approaches 1, what's the limit? 1. As x approaches negative 1,000,000, what's the limit? So it's whatever the limit is that we're looking for. It's c. Exponents. N is a positive integer. Squared, cubed, to the 10th. Think about how we're going to write that. What if this time f of x was x squared? What's the value at 0? What's the value at 1? What's the value at 2? 3? So what is the limit of that function as I approach 3? 9. What's the limit as I approach 2? So aren't I just taking this number here, whatever that is, and I'm just applying this exponent to it? So that'd be c to the n power. Okay, these next pieces, these properties of limits, you can think of them as shortcuts. Think of these as shortcuts. They're going to give us some letters to use here. They say that the limit of some function as x approaches any number we want, we're just going to say that the answer is L. We're going to say that the limit of g of x as we approach any number, we're just going to call the answer k. Scalar multiples, They're saying if you have some number, a scalar, times the function, and you're looking for the limit, here's what's happening. And I'm not going to make you write all of this, but you could take b times the limit of f of x as you approach c. The faster way to think about it and to write it would be b times, well, we know what that limit is, it's L. Because we already found it, or they told us it was L. Some number. The sum and difference property. Here's what it does for us. You've got two functions. Let's say, write this at the top of your paper, this is just an example. Let's pretend f of x is x to the fifth plus 3x squared minus 10. And let's say that g of x, is the square root of x cubed plus 2x minus 5 minus 1. Those look fun, right? Yeah. They're saying if you're looking for the limit of these two functions added together, I seriously doubt you guys want to go to the trouble to try to simplify that and put all that together. You probably don't want to do that. Well, actually, this one won't be that bad, but you probably don't want to go to that much trouble. So they're saying rather than doing all of that work, let's take a shortcut. And because this is my notes, I'm going to write this out this way. You can take the limit of f at x as x goes to c and add it, or subtract, whatever you're doing, to the limit of g of x as x approaches c. In other words, I know what the limit of f of x is. It's L. And I know what the limit of g of x is. It's k. So all you have to do is add or subtract those two numbers together. Next one. To figure this out, you would have to multiply these two functions together. Nobody wants to multiply that out. That means that's a lot of distributing is what's happening. That's not even foiling, because you've got three terms here. That is a whole lot of distributing, and you'd have to turn around and simplify. I'm pretty sure nobody here wants to do that. A bunch of you guys will probably skip that problem. So the shortcut, the property says that you can take the limit of f of x as x approaches c and multiply it by the limit of g of x as x approaches c. And they told you what those are. Limit of f of x is L times limit of g of x is k. So you could find the limits individually and then just multiply them together. It would be way faster than multiplying all this nasty stuff together and then finding the limit. Do you guys see how it's a shortcut? Rather than multiplying the functions first and then finding the limit, you're finding the limits individually and then multiplying them. Totally legitimate. You're allowed to do that. Same process works for dividing, and rather than writing all that out and trying to squeeze it in, we're just going to put L over K, because you know that's where we're headed. But what's the problem with this? What do we have to remember? There's a fraction, and what's our usual problem with fractions? Yeah, you can't divide by 0. So this works as long as K is not 0. If the limit you get there is 0, then you can't do it that way. And this last one, same kind of deal. The limit of f of x is L, so you can just take L to the nth power. Rather than taking this function f of x, this huge thing, and then trying to square it or cube it or take it to the 10th power, you can just find the limit of this guy and then take the limit to that much. It'd be way faster. All right, turn the page. This top theorem is just kind of talking about what we just said on the front side. If it's a polynomial, not any kind of crazy rational function, there's no fraction or anything crazy, then you can just take c and plug it in and you get your answer. The next one talks about square roots. These guys here talk about what do they call it? Trig functions. And for the trig functions, it looks like all you have to do is just plug in c and it should work every time. That is true for sine and cosine. But we have to read here. Let C be a real number in the domain of the given trig functions. Meaning as long as it's allowable, as long as there's a value for x, then you can just plug in whatever you want. Tangent, cotangent, secant, and cosecant. What do you remember about those graphs? How are they the same? What do they have? They have asymptotes. So there are a few exceptions with these four guys right here that you're going to kind of have to watch out for. But for the most part, you can just plug in a value and you should be fine. Okay. Finding limits using substitution. So, back in the day when I was taking classes, this is what our professor made us write out. I'm going to have you write it one time, and then I'll tell you don't have to do it again. But I want you to understand this is what's happening. Based on the properties, the shortcuts we were just given, what we're supposed to do is we're supposed to say, okay, to solve this, I need to find the limit of 3x squared as x approaches 1. Then I need to subtract the limit of 2 of x as x approaches 1. I need to add it to the limit of 1 as x approaches 1. And I used to have to write out the limit part over and over and over and over. It's what teachers wanted, it's what professors wanted, and your professor may ask for that as well. Recognize that when you take the shortcut, this is really what's happening, is you're applying some rules of what you're allowed to do here. What I'm going to have you do is shortcut that and use the properties and say, okay, I can take 1 and I can plug it into the polynomial. So I've got 3 times 1 the quantity squared minus 2 times 1 plus 1. So 3 minus 2 plus 1 is 2. So the answer is 2. The purple piece, I'm not going to make you write that. Just know that that's what's happening. The pink stuff, you do have to give me something. Show me that you plugged it in. I know you can do that in your head, but just show me that you plugged it in, okay? So the limit would be 2. Questions on that problem? All right, let's do the next one. This one's a little different because it's got a fraction. Fraction means what? What's probably going on with that graph? There's an asymptote somewhere, a vertical asymptote. Vertical asymptote? Vertical asymptote? Can you come back to the 6?
Yeah.
So come back to the 6 since it was either first lunch, 5th, 6th, or first.
So I can be able to take it right now.
Alrighty, so this bottom piece means that there's a vertical asymptote there. Where is the vertical asymptote? -3. But they're asking for where the limit approaches 3. So does it really matter where that vertical asymptote is? Jacob, put that up. No, it doesn't matter because it's not a -3. So we just plug in the regular 3 and call it good. Our only concern would be is if that was a -3, and it's not. So we change it to 3 squared minus 2 over 3 plus 3. 9 minus 2 is 7. 3 plus 3 is 6. The answer is 7, 6. Questions? Remember, we're not looking for a y value. We're looking for what is the y value as x approaches that number. Let's look at the next one. We've got trig functions here. If I put in pi over 2, I have pi over 2 times sine of pi over 2. Pi over 2 is how many degrees? 90. I'm going to draw this out because some of you don't remember. Remember that unit circle? Here's 90 degrees. Here's an address. It's 0, 1. Cosine, sine. So what's the cosine at 90? Hello? Or sine of, I'm sorry, what's sine of 90?
1.
1, sorry. So we have pi over 2 times 1 is pi over 2. That's your answer. So the limit is pi over 2. You guys did the last two by yourself. your answers with mine when you're done. Questions? Everybody okay? Okay. Let's move on. This I already wrote once, and then I left off the other box, so you're going to have to copy something down. Sorry. Composition of functions, that's like f of g of x, those kind of guys. Let's say that they tell us, they're going to define something for us, that the limit of g of x as x approaches some number, c, they're telling you the answer is L. All those just stand for numbers. And they want us to find the limit of f of g of x, bless you, as x approaches c. The property says that you can find the limit of g of x first and then plug it into the function of f. Well, we're told that the limit of g of x is L, so you're going to take L and plug it into f, and that's how you're going to find your answer. So that's what that next property says. So the limit of g of x for any number is called L. So if you're looking for f of g of x, you're trying to find the limit of that, all you have to do is find the limit of g of x and then plug it in to the function f. Because you're working from the inside out. Everybody got that copied? So here's your example. They give you two functions, f of x and g of x. First of all, they want you to find the limit as x approaches 1 of f of x. How do you find it? What do we do? What have we been doing? Plug it in. 5 minus 1 is 4, so the limit's 4. Now they want to find the limit of g of x as x approaches 4. So take 4 and plug it in where? G of x. What's 4 cubed? 64. So now they're asking for what's the limit as x approaches 1 for g of f of x. Working from the inside out, and this is my note, so I'm physically going to write this out. The property says, the rule says I can find first the limit of f of x as x approaches 1, and then plug it into g, and I should be good. Well, the limit of f of x as x approaches 1, we solved it. It was 4. So now I just have to figure out g at 4. And g at 4 is 64. On the AP test next year, they will not provide all of that information and you still have to solve it. This top line will be gone. They will probably just give it to you as limits and then ask you the question. So you are going to have to know that property. So what this says again is that you find the limit of this guy first and then just plug it into g. So the limit of f of x was 4. Here's your 4. The limit at 4, they found it to be 64. Does everybody understand what will probably happen in the AP test? Okay, moving down. This is kind of what you're going to see. They're just going to give you the answers to the limits. They're not going to give you the equations. So if we're looking for the limit of 3 times g of x as x approaches c. According to our rules, our properties, our shortcuts, what can I do? I can take 3 times the limit of g of x, which is 2, and get 6. Some of you are going to get confused because there are 2 3's here. This 3 came from here. This 2 came from here. The other 3 had nothing to do with that problem. Next one, the limit of f of x plus g of x. Rather than adding together the equations first, you're allowed to find the limit of f of x, which they tell us is 3, plus the limit of g of x, which they tell us is 2, and you can just add those two numbers together and make it easier on yourself. Next one. The rule tells us you can find the limit of f of x, which they tell us is 3, and multiply it by the limit of g of x, which they tell us is going to be 2, and shorten it up for us and give us 6. Last one, you do that one. We should get the same answer. Questions? Last one. Finding limits when direct substitution is not an option. If I put a 3 in the top of this, I'm going to have 9 minus 24 plus 15. What is that? It does matter. What is it?
Well, it's the 0 on the bottom. So.
Correct, but what's the top? 0. Here's why it matters. If you get 0 over 0, something's going to go off in your brain and you're going to go, that means that there's a hole. It tells you the kind of discontinuity we have. And it means that you've got more work to do than just plugging in a number. If you get a number over 0, it tells you that there's an asymptote. Which still means that you've got some more work to do. But you know what kind of discontinuity you're dealing with. And on a problem like this, you would know immediately to not plug that 3 in immediately. You would know that you needed to factor and reduce first. But there are problems when you may not recognize that immediately. So if you don't see that immediately and you plug it in, you get 0 over 0, you know you need to do some more work. So let's go ahead and factor the top. So we have minus 3 and minus 5 on the top. So what do we do next? Cancel. And what I'm left with is the limit of x minus 5 as x approaches 3. For the last couple weeks, if I asked you for the exact ordered pair, the address for the whole address, not just the x value, how did you find the y part? You plugged it in. So that's what we're going to do here. So we have the smaller version of this. Let's just take the 3 and plug it in, and we get negative 2, and that's your limit. Okie dokie? Okay, your assignment's on the paper there, and I will let you guys get busy.